Good afternoon, ladies and gentlemen, and welcome to this webinar. I hope you can all can hear me. What is today about? Today is about beam design, simple beam design. It's not about frames or portal frames or multi-story buildings. It's about that building block that we all use every day, simple beam design. So I'll just close down the Masterseries itself here and display a little Word document. We're going to be looking at a lot of different things today. We're going to be looking at our simple free beam designers. We have one for steel and one for concrete. If you don't already have those, just go onto our website and log in and request your free copy of these simple beam designers. We'll then be looking at what the full paid up versions give you as an alternative, what the extras are and the benefits, and then we'll be looking at alternative software, i.e. using MasterFrame to do your beams. And there is a free version of the MasterFrame that will do one span beams, or we can go all the way up to the big boy doing up to 99,000 members if you really want to in our steel, concrete, timber. So we're going to be looking at four different aspects, four different ways of doing beam design. So I'll just turn off this little highlighter. So I'm going to restart the Masterseries, but before I do that, I'm going to remove my security key, so I will be starting in evaluation mode, because that's what the first half of this webinar today is really looking at, the beam designers and their free versions. So I'll just start from my little shortcut menu, beam designer. So I haven't found a security key, so I'm going to go in the limited edition evaluation mode, which gives me access to this free pair of beams. And I just say start now. But before I do that, quick look, you'll see that's listing the concrete beam for concrete and steel free beam design as one of the options you have to play with. So I say start now. I come into my MasterFrame or my Masterseries screen, and it gives you this little welcome screen. Because this is an evaluation copy of the software, it lets you have a wee run through of how to use it, but I'll not bother. If you want to, when you try it, click on that and watch it. It'll give you a little insight as to what you can do with the different free and evaluation copies. So I'll just turn that off by clicking here, and we want to go straight into beam design using the beam designers. These are three specialist little programs for doing simple and continuous beams. So here we are, concrete, steel and timber. So I'll start with the simple steel beam designer. Welcome to the demo mode. Yeah, that's fine, but we'll just go straight in. And we'll take a new file. I'll just put this back up into a working directory and just say I'm going to call it demo 01 and create new. The default when you come into this program is a 3-span beam, and you're able to do any loading on this beam but only using these 3 spans. This is our evaluation mode, so you can play around the program. But if you come along, and I think I need my highlighter here, if you come along and delete either this or this, then it becomes a fully functional 1-span beam. So if I press the back key to delete my cursor there, I now have 1 span, at which point I'm now able to change that span. So I'm going to make it 6.54 meters. I can change my grade by clicking on the size, and I can drop this. So I have my UBs, I have my UCs, my RSJs, my hollow sections, my angles, my channels, my T's. And yes, we can use all these section sizes, even in this free version of the program that I'm using. So I'm going to stick with a UB. I'm going to make it S355, and other grades are available. There's a little help document that will tell you how to change those, and I'll just choose a typical section for that, and I'll say close. It's already changed it down here. I'm going to turn around and say that I have beams at a spacing of 4 meters. So therefore, I'm just going to multiply up everything by that and say 5 live load. In fact, I'll leave that back and I'll put it in here. So I'll use this spacing globally, not just for these simple dead and live loads. I'll use this in here and we'll say it's 4 meters apart. Now at the minute this is running a wee bit strange. The screen is displaying these diagrams, which I can move up and down and change their scales for, but I find this a wee bit clumsy on a smaller screen. So what I prefer to use is the 4 diagram layout, where I've got 2 and 2, and I can then move them apart from each other. That's the scales. That's the one I want. Move this down a wee bit out of the way, so I have my 2 beams at the top and 2 at the bottom. My 2 diagrams and 2 diagrams. So very simple. It's automatically for us holding our hand, and it's going to use, in this case, the 5950 maximum minimum values, and we can modify those. It's going to add in self-weight, and since this is a steel beam, I would want a loading case with serviceability for live only. Now by default I probably don't want these columns, so walking across I can come along and I can get rid of my columns, and I can get rid of my columns, but I still have fixity here. So I actually first of all turn off the columns altogether, and I say that the end condition is P for pinned, and therefore I now have a fully pinned beam. It doesn't matter what the section of the column is because I'm not using a column. Be nice and tidy and put 0 in there. Now, having got this initial configuration, what I'm going to do is I'm going to say use this as my default. And just before I do that, I'll go back and I'll say, let's put in the default as being something simpler, 6 meters, and say use that as my default, or even 7 meters, so it's different from the normal. So if I now come out, save that, and take another beam in steel, and I'm going to call this one Demo 2, you will see it automatically comes in, set up at the 7 meters length, those basic default loads, the simply supported, and everything, 4 up as I would call it, 4 diagrams displayed. So that allows me to quickly come in and not have to reconfigure it every time. By using that, save the defaults for new beams. Now 7 meters in span, simple loading. What I can also do here is I can walk along and I can say, well, I wanted to make it a cantilever. By making the last span a cantilever, it means it's cantilevering on one side. So I'm going to just come back and turn that off, and we'll work on our simple beam. Simply supported beam, put on additional loading, and in this case we'll not worry about what the span is because that's only applicable when we have more than one span. I'm going to put an additional point load of 25 kilonewtons. There it is, and we'll make it as a dead load, and we'll put it at 3 meters long, and I'll have a second one of 25, and we'll put that on at 4 meters along. And we can see instantaneously our diagrams update. So I just change my scale and my scale. I can use my little options here to get values as they're displayed, or to turn off the values, and to put on dimensions or turn off dimensions as needed, and display my supports and reactions. So I can see obviously it's pretty symmetrical since I went at 3 and 4 meters, bang in the middle of the beam. If I wanted to make that 2 and 3 meters, I can do that quite quickly by just changing the 2 values. Make that 2, make that 3. It's now off center, and therefore we get a higher reaction left and right. I want to change this increment to show you how it uses, and the increment at the minute is 0.1 of a meter. I can make that up to 0.5 of a meter, and what that now allows me to do is to move. If I go back to my point loads, yes, it still displays the increment value down there, and I can use this button, suddenly walk across. I need to set a span if I want to do that, otherwise it doesn't know what to do. There we go. Click, click, and it moves across, back and forwards, one at a time. And you might ask, well, why would I want to do that? I can just type in the value. Well, the answer to that is that we don't necessarily have to just move one at a time. I can move both of them at a time. If I go half a meter, I can see the effect. And as I'm moving this, I'm seeing my reactions changing, my bending moments changing, my deflections changing. So I can see the influence of the location of an individual load or moving all the loads. And we'll see this to great effect in the next example we do when we're doing the continuous beams in the commercial version of this program. So that's my little point loads, and you notice they're both dead loads. I'll put some partially distributed loads on, and again I'll say span 1 just to be correct, and I'll put them on as live loads. I'll put that on as a live load of 10 kilonewtons between 2 and 5 meters. So there's my partial UDL, and we'll put some values on. There's my factored values. And thirdly, loading wise, we have the varying loads. And the varying load, again, we'll just put a wee span 1 on, or even span 0, wouldn't matter. And we'll tell it starts, in this case, at 3 meters and ends at 4.5 meters. And it starts with an intensity of 2 and ends with an intensity of 22. So there we go, from 2 up to 22 as our climb, as our trapezoidal load. And again, we can move these individually. So I can move this trapezoidal load a half a meter at a time and move it back and see its influence on the screen. So that's our analysis been done instantaneously. But what is it that is actually showing us? It is showing us the loading from all cases. We can see our ultimate case. So here we go, our ultimate, and we can then see our service case, and we see now our service deflections, our service moments. And we go back to all cases, and it shows us the enveloped values, the maximum envelope values. And we can print those out, pretty straightforward, and I'm going to print them to a PDF writer so that we can look at them later. So if I go print, and I say print current brief, I'll send it to the PDF writer, which is called PDF Creator in my case, and I'll say print, and there it goes, and it puts the diagrams, it puts the summary results, it puts the analysis results for the ultimate and service. So under service it doesn't give forces, just deflections and reactions. That's what I would want. So now I've analyzed my member, I want to do the steel design. So design, steel design, and we're straight into our steel design. We can see it fails because it's gone blue, and I would first of all set up the criteria. So I would turn around and say that laterally it is fully restrained, so I don't need to put any additional portions on. I can come along and I can say, well, fully restrained, I'm going to need a bigger beam because it is a reasonable span of, I think, 7 meters. So if I go up by serial size, my 406s, my 457s, my 533s, I will find that I eventually get a section that works. As you can see, this is the first section that works, 162 kilograms. Now, that was quite simple, just walking up through the list. But this list is ordered in what I call serial size. Instead of serial size, I want to change it to be sort by weight. So now, from the 160 to 152, all the way down in weight. So if I come down to a weight that I know will probably fail considerably, by nearly 90%, I can then walk back up again by weight order and see what is the lightest section that's actually going to work. And it's a deeper section, it's a 686, but it's only 125 kilograms. So I've saved myself there, nearly 20%, 18% in my weight of my beam. So the choice is yours. What you can also do is you can say that I don't want any members that are greater than 650 deep. So that's the minimum. Say minimum 400, maximum 650. And it's now switching over to a different section that's going to work. Coincidentally, all it's doing is it's just eliminating the sections that don't meet that criteria from our list. So from 400 all the way up to this heaviest section. So rather than scrolling up and down through these one at a time, it's even quicker to use this auto size. So I just size that and it walks up and finds the member for me. So in this range of sections, fully restrained, I need this 610 by 125 kg section. Now, if it's not fully restrained, if it's unrestrained, obviously we could be in big trouble. So let's go back and define that it's got a restraint length of 1L. It's now buckling mad, and I can come on up, and choose a different section, and I need to go quite high. So if I say auto size, it needs to go up to 219 kilograms to work unrestrained. And of course the third option is something in between. So what happens if we have restraints at 2 meters and 5 meters? If we do that, we first of all set this to 1L, and we secondly come along and say the first portion, that's better. I had auto restrain at connected members turned on, and that's something that doesn't really apply to these simple beams because it does not know anything about connecting members. So I said 2 meters and at 5 meters, so it would be at 3, and then whatever the last length is, in this case it will be another 2. So I can say 0 to 2 meters is fine, 2 to 5 is fine, and 5 to 7. So would we get away with a lighter section? Let's auto design. Even looking at this one, when I go auto design, it still designs it for all 3 components, all 3 zones. So it's looking after and holding everything correct. Now, I put my loads in to BS. I put my design as BS. But there's no reason why I cannot work to EC3. And I can work to EC3 by just switching the switch, and I can now see that this is now working to EN 1993 2006. Obviously my load factors are slightly different, and if I just come back out again very quickly and come to my beam data, it's already set my load factors, because this is instantaneous, to the EuroCode factors, and I can quickly go into design using this button as a shortcut, and I'm in here and I can see it works, and I can go auto design and see if I get a slightly better solution than the 149 kilograms. And in fact, because I'm not sorting by weight anymore, it's gone for the shallower, there we go, by weight. We got to 140, so we actually saved 5 kilograms by going to the EuroCode. And I'll print this out for you. Print design output. And I don't really need to worry about the Appendix G because it doesn't apply to this beam. And I just go print and print it to my PDF writer. and just back to my program. So it's now got 4 pages in its little PDF file. I'm finished with that, so I'll just close that and let's have a quick view. Doesn't matter what it's called, just save that. And we got our first one, our load diagrams, our loading, our analysis results, and then finally on the last page the summary of our results. Of course, we should have probably been more complete and printed out not just the summary but the actual design checks themselves. So I'll just do this again for the design checks. I got 3 separate pages on a separate PDF and save that. If you have a more expensive PDF creator, you would be able to join those 2 documents together. Otherwise you go back and do it all from start again. So here's my design of my first portion, design of my second portion, and design of my third portion. So that is your simple steel beam design. It'll do single span beams, it can do cantilevers, it can even do partially fixed beams. Because if I went back to my supports, I could even go and say part /25 and get a partial hugging up of that to get me an unusual configuration of design. It will do point loads, it'll do distributed loads. What can't it do apart from additional spans? Well, if I look at my little document here, I actually created a wee table for you. And if we're the simple free beam designers, be it for steel or concrete, what we can't do is obviously multiple beams, and we can't do, more importantly, minor axes or axial loads. We can't do torsion design. And we'll look at doing torsion and minor axis loads in a moment. But let's look at the full version. So if I just come out of this, say yes and yes, I'm just going to exit from the Masterseries a second. I'm going to put my security key in. I'm going to restart the Masterseries. And I'm going to come along into my Beam Designer again, Steel Beam Designer. And I'm going to choose my beam I did previously. Looks no different. The only difference is I could add in a 2 meter additional span. With a different loading, I can type in that the loading here is, by default it will assume the previous. So I'm going to say the dead load over here is only 2 meters per meter square and 2 meters per meter square live load. So I've got my little beam here. I can come along and I can say cantilever the last span, so it's now working as a cantilever, which hogs that back down or sags that down and puts a very small hogging moment there. So the cantilevers are not a problem. So we can do a little back span arrangements using this. I can have up to 16 spans. So I can put in another span, 5 and 3, and you'll see that they're all very light loads compared to the first one. So if I went and said here I have 6 kilonewtons and it's 5 kilonewtons, then it goes back and makes the last one the same. So we now have a multi-span beam in steel. And I said I would come back to this moving of loads because at the minute these are referenced to span 1. So if I take my half meter movement and I start to move these loads, there they go, these 2 loads, I can move them, but basically once I get to the end of the beam I can't move them any further. They can't go beyond the end of the beam because they're referenced to span 1. If I change that to span 0, then in a multi-span beam that allows me to put them anywhere. So I can now move them over to here. So they're basically 10.5 meters from the origin. And that's great for moving your point loads about. The other nice thing we have when we have multiple spans is we can move our supports about. So if I want to move that support to try and balance these loads up and put some of that load over onto this member, I can come to my supports and I can say I want to move support 1, no, 2, 3. So I move support 3 and I start to move it the other direction. You'll see the shearing and everything changing. So we're getting a sculpted and modelled set of bending moments and shear forces and reactions for where our new location is. And that can be quite handy if you're doing a concrete beam, which we will do in a moment. And in this concrete beam, you're trying to work out pile loads and reduce pile loads where you have to. I could, for example, say, well, actually, if we pull this across, then we might get a reduction down below 500 for our shear, our reactions. So now the reactions below 500, and we could even just pull this one over again to balance it out and make it more balanced. So that is the same. It's the same program, just the commercial version you have up to 16 spans. If you have a power pad license, you get a 3-span version of this. So we'll go back into steel design, and it's slightly more significant because we have 8 design checks. We have our first span, we have any Appendix G loads in that first span, and you'll notice obviously that we can really redesign that coming down, coming back in the first span. If we resize that, auto design that, we can see that we can get a lighter beam because it's continuous. We're now down to 46 kilograms. Wow, that's a big difference. Span 2, we've got our overall span, and we also have obviously our Appendix G checks for the unrestrained compression flange. Since this is going into full uplift, it's unrestrained over its full length unless you have stays coming down or the slab tucked into the web of the section and secured. You would have to look at this check. Obviously we're doing the EuroCode type design at the minute. If you went back to a more familiar BS, just for simplicity of design, then you would see it being more applicable. I'm just going to turn off my section sizes and put on little dots so I can see my beams a lot easier. And we can see that the sections that we use can be chosen, the design can be chosen by picking the member. We don't have to drop this list. We can actually move to section or to span, and every time we choose, we switch between the beam and the Appendix G. So I've spent half of my time today, or just over, talking about the simple steel beam design, the free version and the commercial version. What I'm now going to do in an accelerated fashion is I'm going to look at concrete design. I don't really need to go into looking at the concrete, sorry, I just closed the program by mistake. The single span version of the concrete. We'll look at the commercial version because it is the same, just for more than one span. So let's look at a concrete beam designer, and we'll find we have a concrete beam here that's been designed by somebody, and it's got 1, 2, 3 spans plus, I assume it's a cantilever. I can just check there, it says yes, last span cantilever. So we have some unusual loading on this, and we have our multiple cases, and obviously we've asked it in this case to use alternate loading patterns rather than just maximums and serviceability. So we've done, that's the only difference we've actually applied here. Instead of having section properties that are UBs, UCs, RSJs, hollow sections, we have here our R for rectangular, L for an L-shaped beam, and we could even go T for a T-beam. So we can invert or create a T-beam with some dimensions, and we'll just put in a narrow here, and now we have a T-beam. The loading is pretty straightforward, and I'm just going to go straight into design because everything else is the same as for the steel beam. Into design using the little shortcut button rather than from the top menu. We're coming in and we're coming in with a typical design, and in this case the person has already done some redistribution of the moments. I can see that because of the grey line, the elastic line being dropped down to a plastic redistribution. So if I just come along and in the redistribution take away all the redistribution, that's now 0, and come back to my beam design. So the right hand side actually need to redistribute as well. There we go. Move to the next span. I can pull that off so they had locally done it, and for the third span, and again I'll put those little dots on. I find the dots easy to distinguish from one span to another. Interesting. We have some fun that we didn't notice previously. If I just come back out to my analysis, one thing we did do was we put in a minus sign for the span, and that inverts the section, so we end up with our L beams and our T beams being inverted. So therefore 1200 was probably not a best solution. We could go for say 600 here. Come back into our design and we'll see our first section is our rectangular. Our second section is an inverted L with our loading on the side and a most annoyed design, which we'll look at in a moment. And our third section is an inverted T with loading on both sides, and the fourth section will be the same because we didn't change it. So in here we have our design, and we see we're getting failure symbols here, and we've got quite a lot of bars. So we might decide that we don't want to put more bars in. We don't want to put 9 bars in and try and make that work. We don't want, we've actually limited here to being only 8 across, so we would need to change that. If I just go to options for a second and go into display and tell it not to use pop-ups, then I will be able just to right mouse click and change my results. So looking at this, I could get away with 9 H20s or 8 or 7, and those wouldn't work because I can see the failure symbol here and here. So my solution to make that work, bigger section, more bars, or as the person had done previously in this frame, redistribution. So 5–10% redistribution will just drop that down enough to work with the 8 bars. We've got a little problem here, so we need to make these bars go out further so that they're still effective at this point. Pull that on out, and now this section works. In bending, it has a problem in shear, I can see, because of this little blue diagram, and I just double click and I can see that I actually need heavier links to make this work. So coming to my links, I can go for the right hand side, and I have 10s at 150, so I could reduce those down to 125 or 100, and I would probably then need to put in a couple more. So 15 sets of 10s at 100 will actually work. I could make them into pairs, and then I could increase the pitch again to 200 and reduce the number. So different solutions are applicable or available to you. So what we're doing here is we're putting tens, but we're putting pairs of them together rather than going up to 12 mil bars or to a tighter pitch. So pairs at 200 is the same as singles at 100, but allows you to get your poker in and out. The choice is yours. We're only demonstrating the possibilities to you. Now, this is where we end up having awful problems in shear and bending, because really the section is not meaty enough to work. And this is one of the nice things about the concrete design. You can change your section sizes and see what the effect is. So I can say, well, actually, if I made that, say, 600 overall depth, will that help? And it's beginning to help, but not totally, because of the problem with the torsion. What's happening is this load is pushing the whole beam and causing it to twist and torsion. So my solution would be to either get the load away and pull it in, or to decide that it's not got any torsion at all, or make the section squarer to resist torsion, because it's reducing my capacity. I'll have a quick play with it to see what I can do. I think that obviously we may need to go up to 6 bars and 632s. That's sort of solving a bit. And 40s is a wee bit of an overkill. But if we went up to say 32s, and likewise here, I can drag that bar across. We're beginning to get our solution. And obviously over here, we might need to drag this bar considerably further over, and we just have a little problem there. And remember, we can distribute the forces, which causes me a problem down here. So oops, pull that back up. So the configuration of the section is not right. It's going to be too congested. We need a bigger section. So let's play around with our section again. I'm going to make it a lot broader, say 400 wide, and things are beginning to look better. And I'll go for, say, 700 deep. But also, as I said earlier, we could try and get rid of the torsion if we don't have it by saying that we only put a small amount of load. 10% of the load is eccentric, the rest is concentric above. So that is reducing my problems, and it's certainly solved my moment problems. My shear, I still need pretty heavy links. 8s are a bit narrow, so I probably want to come along with my nominal bars and make them 10s or 12s. And they're still causing me problems at the supports. And of course I haven't considered shear enhancement, so I can enhance the shear and make that work. So as horrible as it looks, that is a solution to my beam. And I can walk along and do the same with the other beams. But this isn't a webinar all about concrete design. This is just about what you can do with single span beams. If you want more detailed usage of the concrete design component, look at the previous webinar we did on concrete design. So I want to come back out again, and I want to go into the third of these beam designers, and that is the timber beam designer. And I'm going to take a new file, Tommy, and create new. And again, I'm going to go in this case for a single span beam. The timber is not available as a free program as a single span one, because basically that will be too useful to you. So get rid of my columns, no upper columns, remove the lower columns, and set the fixity to pinned. And I'm going to come back and reduce my span, say, to 2.4 meters. And the section's pretty hearty, to say the least. I'm going to go for 100, so 4 by, I think, 250, 4 by 10 section. And that's going to give me these deflections of 3.5 millimeters in my timber section. supports are there. I'm working with C22 timber, and it's going to be internal use. So now it's got all the timber facilities because we're using a timber program, and it's going to be one piece, and I can put my other loads on as I wish, and then I can go into my design and design the section. And I can design the section for breadth or by width. So it's sorted by width, so it'll try and use the narrowest width it can each time. I will find that it's just overstressing with this little small section, and a 75 by 220. I'm probably going to go for, that's the biggest one that it has in its book, and that's pretty, I wouldn't say lucky, but it's showing us that our 100 by 225 or 250 was pretty good guess. Loading, again, we can set the term, we can set the service class for timber, and if it was a sort of a single beam, we could say whether it's made up of 1 or 2 or 3 pieces. So if it was like a lintel that was made up of 2 pieces together, we could use, maybe a slightly different solution. So that's the timber design for you, and it is very simple. It is also for multiple spans. So you could have a 2.4 with a 1.2 meter cantilever coming out off the end of it, and if I suddenly say the last span's a cantilever, we're getting an 8mm deflection, which is not bad. We could probably live with that. So we have a little balcony, and we're designing it in timber with our back beam taking our rotation and keeping it upright. It will work. So that is the simple beam designers. That's the steel, the concrete, and the timber beam designers, be they the free versions or the not so free versions, the commercial versions. If you want to do more complex things, if you want to do a beam with torsion on it, you would need to use MasterFrame. So I'll come into MasterFrame and I'll take a new file called OneSpan and create new. You have the free OneSpan version of MasterFrame available to you as well. And we'll say it's a steel beam, and we'll go for a channel hollow section. There they are, square hollow section of say 250 square by 8, and we will now, using MasterFrame, very quickly edit the coordinates and make it 3 meters long, and we'll now put some loading on. So there's more learning to use this version, but it's more powerful. So loads, member loading. I can come along and say give me 2 UDLs, give me a torque, give me a UDL, give me a point moment and a point load. So a dead load of 10, a live load of 20, an eccentricity of 200 millimeters. I'm actually going to ask for another eccentricity and then just move this up in the list to there. And this means that this load here of 5 kilonewtons is eccentric from the shear center of the member by just 200 mil, and then these loads are not eccentric at all. But I'm going to put a point moment in of 30, and I'm going to put it in on the X axis, and then I will have a point load of 25. So this is a 3-dimensional system because it's got 3-dimensional loads. So I better go and look at my restraints, nodal restraints, static. I can say this one is fixed. And then I can say I got a spring support over on this side that has a spring stiffness in the X of 1000. So it's going to take some torsional resistance. I'm just playing around. So analyze, space frame, output, graphical output. Here we go. Bending moment diagram. Not too bad. Deflected shape. Not too bad. Torsion diagram. We didn't develop any torsion, did we? Here it comes. Yeah, we actually get a most unusual torsion going from one direction to the other. See the smaller spring resistance in this end and this pointy bit. And the pointy bit is really because we didn't tell it where the point moment existed. So member loading. We told it we had a point moment, but we really need to tell it where. So I'm going to say it's 2 meters along the member. Let's just reanalyze. Space frame, output, graphical, torsion, and you'll see now that the torsion is suddenly kicking in the opposite direction due to this point moment reversing its direction, so to speak. The shear and the deflected shapes. So those are all pretty straightforward. We can now go and design this. So what I was saying to you, ladies and gentlemen, is that the single span free version of MasterFrame will allow you to design your little torsional beam. Don't tell the boss. So we're going to not ignore torsion, we're going to design torsion with the ends free to warp. And we can see down below we now get our torsional bending and our torsional rotations, and we can see that we're rotating by 0.336 degrees, and that's because we are using a closed section. If I said, well, instead of a 250 by 250 by 8, which is 60 kilograms, if I put in a 254 UC, what would happen? And I always enjoy doing this because it's around that weight, and you can see similar weight, but we're failing miserably on torsion and deflections. So in an open section we would need nearly 80% more material to resist that, and we're getting a far bigger degree of torsion. So that's your free steel design for unusual things, because I put a spring torque in. I could have put a spring settlement in as well, but obviously it is only single spans. The Rolls-Royce solution for doing the unusual is to look at the full MasterFrame with the design you require. And if I actually went and said open new and then went recent ground beams, these are all little concrete ground beams with supports, no pin releases, just supports in different places. So we got a little beam here, and this beam's going to be, this cantilever is going to be resisted by here, and we're sort of going to get a torsion along this member. So this arrangement of beams in, I don't know, some sort of housing development or something like that can be designed. Well, actually, before we design it, let's quickly look at the output. Graphical. Bending moment diagrams. There seems to be no minor axis moments, and there's a reason for that, and that is we told it to ignore torsion. So we don't get the torsion in this member. All the torsions are all back down to virtually zero, except where they can't be, where they're internal. So they're all nearly zero. Deflected shapes with diagrams. We'll see our little cantilevers are the bits that want to walk around. And it's quite interesting, that little cantilever, because of the length of this beam, is lifting up rather than settling. And this is, for beam design, this is what you do when it's complicated. But if I went back into the editor into options, there's an ignore torsion. If I turn that off, reanalyzed, space frame, cancel, output, graphical. This time bending moment diagrams are going to go blue and red, primarily red, but they will go blue as well. And if I turn on my torsions, I can see my torsions now exist, and I will be able to design for those. So when you've got torsion, when you've got biaxial moments, when you've got axial loads, you really do have to come into the full frame analysis. And that is, in summary, where I was stipulating here. Torsion design, you need the proper frame analysis. EuroCodes is covered by all of them. Grillages, you need the full master frame analysis. Springs and settlements, you need the full master frame. Axial and major and minor moments, you need a master frame component. But if it's just either simply supported in single span beams or planar continuous beams, then the beam designers, the free or the commercial version, will do your job. I will actually send people this little table. I'm going to have a wee look and see, are there any really questions that I need to cover? Martin, anything you want me to cover? Do we do our lap lengths and anchorages to EC2 in the concrete design? Obviously, yes, we do. If I went back to my little frame, this is a concrete frame, remember? So if I went into design, concrete design, and this is where it scares people. This is normally our little simple capacity diagram. Trying to find one suitable. Loaded but not too heavily loaded is probably better. No. Let me see. Oh, that's interesting. That'll do. What we can be able to do, the loading is quite light actually, and this is because it's what you expect in the old ground beam type arrangements. But I'm going to, in places, drop this down to say to 3 bars, or maybe a longer span. Yeah, this might be better. If we take this one, this is to BS. If I move over to EC2, obviously the loading is slightly different, but we get a totally different arrangement because we actually, this isn't a bending moment diagram anymore, but a force diagram for the tension steel. And we have this shear drag applied as well. But as well as the shear drag for our capacities, we then have the lap length effect on this. So the bars become ineffective as they move along the lap length. So here we're dealing with just these bars here, the 412s. At this point in here, we've got the 412s plus 412s giving us a slight increase. So we're now up to, in fact, 812s, and then we're tapering away again on the other side. So yes, we are considering all those curtailment points and everything to the EuroCodes. Probably in this case not the best example. Where's concrete grade specified, James? It's really to do with the concrete program rather than just this little beam program. But if you go into your options, you have all your different settings, and one of those is your grades, your steel data, So concrete code, schedule, your bars, and you'll also see your concrete grade for your beams in this case. There are no columns, so we don't see them. There's no pads, so we don't see those, but we're using C20, 30 concrete. I can go up to C40, 50 concrete if you want. So that's where you put your grades. So just to summarize, I'll send you out a little table of what the different versions can do. If you're looking to get a more in-depth help on using, say, the steel design or the concrete design, you want to look at their detailed webinars. So if you just log in to the Masterseries, use your login credentials. When I click on the login, you come along to training videos. Now we will be posting this video up onto the website for you. All the other ones are here. So webinars, we have the previous version of this we did about a year and a half ago. We have the detailed coverage of the commercial versions of these beam designers. We have concrete design, a specialist webinar on concrete design. There's one on steel design as well. So those are all worthwhile viewing and watching to learn the ins and outs of the steel or the concrete design. Plus all the big stuff, all the power pad webinars, all the masonry, the 3D model managing webinars. And we have also got tutorials. So some of the simple tutorials are available for you to follow as videos as well as tutorials. All your documentation is available here or online. So you can go into manuals and view your manuals here, or you can access them directly from your PC. So ladies and gentlemen, I would just like to thank you all very, very much for attending today. Thank you very, very much, and goodbye.